Hello everyone and welcome to the Unit 8A.4 video, which is more practice with synthetic division and long division. And some of the problems you will recognize as similar to previous notes. And some of the questions have the same idea but have a little bit more difficulty, which is why we wanted to make a video to go along with this extra practice. So this first example says, given that x equals 2/3 is a 0, or in other words, a root, find all the remaining zeros or roots of this cubic polynomial. Now, if this is a 0 truly, that means that after we do synthetic division or long division, my remainder must equal 0, because it means it goes into the polynomial evenly. So because this root technically comes from the linear factor of 3x minus 2, if you think about it, if you set 3x minus 2 equal to 0, you would get 2/3 as a root. So because this is linear, remember that you can do synthetic division if what you're dividing by is a lead power of 1. If anything higher, you'd have to do long division. So because it is linear, I can do synthetic. So I can have 2/3 as my root, and I can copy all of the lead coefficients in order: 48, -80, 41, and -6. I am not missing any terms, so I do not need 0 as a placeholder. So if I were to start my long division, I would first carry down the 48, and then I would multiply 2/3 times 48, which would be, so 3 goes into 48 16 times, 2 times 16 gives me 32. If I combine down -80 plus 32, I get -48. If I multiply -48 times 2/3, because remember this process is carry down, multiply, carry down, multiply. 3 goes into 48 16 times again, but now we have -16 times 2, which gets me a -32. If I combine 41 minus 32, I get 9. And then if I multiply 9 times 2/3, 3 goes into 9 3 times, 3 times 2 gets me 6. And when I combine down, I get a 0. Which is good, because my remainder is 0, I know that 2/3 is definitely a root, and I know that 2/3 is a factor of the polynomial. So remember, that terminology is important. If you get a remainder of 0, that means that this truly is a factor of the polynomial given. Also, what's good to remember is what's left over is usually a degree smaller than what you started with. Because we started with a cubic and we divided by something that was linear, we'd have to be left with a quadratic. So we'd be left with 48x squared minus 48x plus 9 equals 0. Also, please remember that this 0 is dealing with your remainder. This 0 is just saying that because you're trying to find the x-intercepts or the roots, you're really setting f of x equal to 0. If I continue to factor or use any method, I notice that there is a greatest common factor of 3. And if I take that out, I'm left with 16x squared minus 16x plus 3 equals 0. Because I have a lead coefficient other than 1, I can split the middle term. So if I did a times c, I would get 48. Write down my pairs that multiply to be 48. 3 and 16, 4 and 12. 4 and 12 will combine to get me a -16. So I'm going to leave my 3 there, write 16x squared, split this into, let's see, both of them would have to be negative in order to get a -16, minus 4x minus 12x plus 3 equals 0. I would have to then group. So I'd have 3, 4x minus 1, carry down the negative, greatest common factors of 3, also left with 4x minus 1 equals 0. So I'd have 3 on the outside, one of my parentheses would be 4x minus 3, and the other would be 4x minus 1. And so if I set those equal to 0, I would get this root to be a positive 3/4, and I would get this root to be a positive 1/4. So to answer my question, we want to know all remaining zeros, and I will just list all of the zeros. The first 0 I was given was the 2/3, so my answers would be 2/3, 0. 3/4, comma 0, and finally 1/4, comma 0. Those are the roots. And that makes sense. It is possible to have 3 roots when the original polynomial was a cubic. Next example, divide the top by the numerator by the denominator. This time, because the denominator is x squared, I cannot use synthetic division. I have to use long division. So I'm going to set it up for some long division here. So to start this problem, we would ask ourselves, how many times does x squared go into 2x cubed? So if I take 2x cubed divided by x squared, that would be 2x. So I'd have a 2x first, and I put that over the like term, and then I would multiply backwards and get 2x cubed minus 4x squared plus 2x. And then I am really subtracting all of that, so all of my signs change. This is a negative now, positive and negative. These two terms combine to be 0. These two terms also happen to combine to be 0, but if I combine negative 15 minus 2x, I get a negative 17x plus 5. So when I go back and do this again, I ask how many times could x squared be divided into negative 17x? Well, it is not going to be divided in evenly because this power is smaller than this one. So this already is my remainder. So my answer would be the polynomial 2x plus the remainder of negative 17x plus 5 over the divisor of x squared minus 2x plus 1. The next problem, use synthetic division to find all factors of this cubic function, given that root 3 is a factor. Now, this one's unusual, but remember that this, even though it is a square root, does come from x minus root 3, so this factor is still linear, so we can use synthetic division. If I write my lead coefficients, I'd have 1, I'd have positive 2, negative 3, and negative 6. And if I start my synthetic, I would bring down the 1, and then I would multiply root 3 times 1 to get root 3. Now here's where things get a little tricky. If I'm combining down, I cannot combine 2 and root 3, so I'm going to keep it as 2 plus root 3. Then if I multiply root 3 times 2 plus root 3 and distribute, that would get me 2 root 3 plus root 9, which is 2 root 3 plus 3. So I would put 2 root 3 plus 3 here, because that's what I got when I multiplied. And then when I combine down, if I do 2 root 3 plus 3 and then minus 3, these cross out, and I'm left with just 2 root 3. If I multiply again, and multiply 2 root 3 times root 3, things are looking a little nicer now, because I'd get 2 root 9, or 2 times 3, or 6. So here I'd get 6. So funny enough, even though the question looks strange at first, we still did get a remainder of 0, which means that root 3 is a factor of the polynomial given. But we want to find all other factors. We know that 1 is root 3, and what we're left with now is a quadratic. Again, we're given a cubic originally, so we're left with 1x squared plus 2 plus root 3x plus 2 root 3 equals 0 if we want to find the remaining roots. Now, even though this question looks strange, I'm going to rewrite it a little bit more nicely. X squared plus 2 plus root 3x plus 2 root 3 equals 0. I'm going to try to factor this without split the middle term because I do not have a lead coefficient higher than 1. X squared is x times x. What times what can give me 2 root 3? Well, I can multiply 2 times root 3. Let's see if that works. If I want this to be positive, both of these would be plus. If I think about foiling backwards, I'd have x squared plus 3 root x plus 2x plus 2 root 3. And that would work, because if I added 2x and root 3x, I would get this middle term. So this is factored correctly, which means that my other roots are -2 and -√3, which means my answers as intercepts, my original root was a positive √3, so it would be √3, 0, -√3, 0, and -2, 0. Given x plus 3 is a factor of this, write the function as a product of linear factors. So this is one that I want to pause. I would like you to recognize that if this is a factor, the root is actually -3. I would like you to do synthetic division to find all of the other roots, and then I will come back with that work and we'll talk about what the linear factors means. So please pause now to find the rest of the roots yourself. Alright guys, feel free to take a minute to look over my work. I first did synthetic division, and when I did, I got a remainder of 0, and I was left with x squared plus 0x minus 48. If 0x is not really there, so I was left with x squared minus 48. I solved using square roots and got my other two roots to be plus or minus 4√3. So my roots right now are -3, positive 4√3, and negative 4√3, which means that if I would like to write my answer as a product of linear factors, that means we want everything in this x plus 3 format. So my function would be working backwards. If my root is x minus 3, it came from x plus 3. If my root is positive 4√3, it came from x minus 4√3, and negative 4√3 as a root came from positive 4√3. And just to check back, yes, we want completely factored form. We do not need to multiply this out, so this would be my final answer for this problem. This last example asks to divide x minus 2 using long division. And I may do it both ways just to check. You could do this using synthetic division or long division. So what I'd like you to do again is pause the video and try this either by long division or synthetic and see what your answer is. And then we'll talk about why is the remainder equivalent to f of 2. So please pause now. So guys, during the pause, I did both methods. I did long division over here and synthetic division over here. In whichever method you used, your answer should have been 10x squared minus 2x minus 7, and then the remainder should have been -10 over the divisor of x minus 2. Now, what's good is that if you did synthetic division, I would try to do it with long division, see if you could get the same answer. If you did long division, I would do synthetic division to see also if you would get the same answer. It's a good idea to check yourself. Now the final part of this video is asking why is your remainder equivalent to f of 2? Well, it's equivalent to x or f of 2 because of something from an earlier video called the remainder theorem. The remainder theorem states that when we divide a polynomial, any polynomial, by a factor, in this case our factor was x minus 2, then the remainder, when we divide this polynomial by this factor, is that the remainder will be the same as if I had plugged in f of 2 originally. And this is a good way to check to see if something is a factor or not. So I'm also going to write a note, check to see if a factor. I know that's not a perfect sentence, but you want to check to see, that's what the remainder theorem is saying, that you can check to see if something's a factor before you start. So in this problem, for instance, if I had plugged f of 2 into my original polynomial, which was 10x cubed minus 22x squared minus 3x plus 4, I should get the answer of -10, which is my remainder here. So let's see. 10 times 2 to the third minus 22 times 2 squared minus 3 times 2 plus 4. That would be 10 times 8 minus 22 times 4 minus 6 plus 4. 80 minus 88 minus 6 plus 4. That would be -8 plus -6 plus 4, which is -14 plus 4, which does get me -10. And because this remainder is not 0, the x minus 2 was not a factor, but it does tell me that my remainder is -10 before I do long division at all.